So today in this video we're going to go over variation functions and simplifying rational expressions. One special type of a linear function is what's called the direct variation function. It's got a relationship between two variables x and y that can be written in the form of y equals k times x, where k cannot equal 0 because obviously k equals 0, then it makes y equal 0. In this relationship, k is the constant of variation. So for the equation y equals k times x, we say that y varies directly with x. Oops, sorry about that. So in example 1, it says, given that y varies directly with x and y is 27 when x is 6, write and graph the direct variation function. So the first is write the equation y equals kx. And then we're going to fill in the variables, okay? So it says, given that y varies directly, so we're going to say 27 equals y, right? And then we're going to say k times 6, right? So what we want to do is we want to find out what the k is, okay? So what we're going to do is we're going to divide both sides by 6 here. And we're going to say that k is equal to 4.5, because when we divide 27 by 6, we get 4.5. Okay, so our equation of direct variation is y equals 4.5 times x. So now what we're going to do is we're going to plot some values. Okay, so I know some values to plot. Now, what you guys could do is you could put this in Desmos and graph it and see what it looks like. So we might want to do that and then decide what points we want to plot. So hold on just a second. So when we look at this, we can see that when I plot y equals 4.5x, which is what this is, 4.5x here, then we can see where our points are. So let's just see when we're at negative 10. What is that value right there? That's negative 2.2, negative 9.9. So let's just see if we can find a point. So y'all see that? Trying to see if we got a good point here. So if we do 10, now let's just, yeah, so that's like negative 2.2. So I don't think we want to go beyond 3. We could try. Let's scroll out a little bit. So if we do 3, 1, 2, 3, let's see where it intersects with 3. Right about there, it looks like, yep, pretty close. So that's about, yeah, I'm just trying to find. Yeah, that's about 13.5. Yeah, so we can go ahead and try that. So what I'm looking for, y'all, is some values that I could plug in. So obviously we could plug in 0. We could plug in negative 1 here. We could plug in negative 2. And we could try negative 3 because our graph only goes up to 10 and negative 10, right? So that's the only reason I want to look at it on the graph, okay? So now what I'm going to do is I'm going to put some values in here. So if I put negative 3 into 4.5 times 3, that's going to give me a y value of negative 13.5. And that's going to be off our graph. But then we go negative 2, that's going to give me negative 9. And then negative 1 is going to give me negative 4.5. And then 0 obviously is going to give me 0. 0 times anything is 0. Then we could go right back up with 1, 2, and 3, right? So then we've got 4.5. Positive, we've got a 9, and we've got a positive 13.5. Okay, so now all we need is a few points here to graph this, right? So let's go ahead and we can't fit this one on the graph because the 13.5 is more than the graph, but we can go at negative 2, negative 9. So at negative 2, negative 9, we're down here, right? Right about there. And then at negative 1, 4.5, we're about there. And then we got 0, 0, right? Then we've got 1, 4.5 right there. And then we've got 2, 9 again. So this would be about what our graph would look like. So let's see if I can do a decent job at drawing this, y'all. So decent. Not perfect, but you guys get the drift, okay? So that's our direct variation equation graph, all right? So now we want to look at some examples of equations of direct variation. So the cost of an item is in euros varies directly. This is our key phrase right here. As the cost of the item in dollars, D and E, 3.85 euros, or however you want to pronounce it, when D equals $5. So when D, then it says find D when E is 10 euros. Okay, so we want to look at our equation y equals kx, right? We do that because it says varies directly. It says as the cost of the item in dollars and euros when D, so if it says varies directly. So euros varies directly as the cost of the item in dollars. Okay, so what are we going to write? So it's going to be E, the euros vary directly with what? The dollars, right? So that's how we're going to write our equation. So now we're going to put in the values we got here for E and for D, and we're going to be able to write an equation for this. So we're going to say that 3.85 is equal to K times our $5, right? So we're going to divide both sides by that 5. So K is going to be equal to 0.77. Okay, now we can write the equation of direct variation for euros and dollars. So that's going to be the euro equals 0.77 of a dollar, the cost of a dollar, right? So if we want to find out how many dollars a euro is worth, so we're going to put the 10 over here and we're going to say 0.77 D, right? And then we're going to divide both sides by our 0.77. So that means our dollars are going to be what? $12.99. Okay? Which, because when you divide the 10 by 0.77, you get $12.99. Okay? All right, so now you guys try this next one and come back to me when you're done. So this one says the perimeter of a regular dodecagon. I can't say that, y'all. Dodecagon varies directly as the side length S, and P is 18 inches. So it varies as, so we got P equals K times S, right? That's what we were told. All right, so now once again, we're going to put in the values that were given for our P and our S, and we're going to find our K. So we got 18 is equal to 1.5 times K, right? It's SK, KS, it doesn't matter, okay? So we're going to divide both sides by 1.5. That's going to give us our K, right? So our K equal to 12, okay? Then we're going to write our equation of direct variation. So P equals 12 times S, right? Then it says find S when P equals 75. So that means we're going to say 75 is equal to 12 times S. So we're going to do what? Divide 75 by 12, right? 75 divided by 12. So that's going to be 6.25. So it's going to take, it's going to have a side length of 6.25 inches, right? Okay? So our next concept is similar but a little different. So this one says an inverse variation is a relationship between two variables x and y that can be written in the form of y equals k over x, where k does not equal 0. For this relationship, we say that y varies inversely as x. So given y varies inversely as x and y equals 4 when x equals 5, we're going to then write a graph and inverse variation function. Okay, so here again, what we're going to do is in that inverse variation, that x and y, y'all are in your notes, so for you to write down. Okay, so so this time I'm going to actually write that equation again. So y equals, this time, k over x, right? So we're given that y equals 4, right? And then we've got k divided by x, right? So now how do we get rid of that 5 that's in the denominator, y'all? Don't we multiply both sides by it? We do. So that means my k is going to be equal to 20, right? So when we write our equation of direct variation, it's going to be y equals 20 divided by x, okay? So I'm going to use a table again to graph this. Now, once again, you could put this in Desmos and check it there. So we can do that first. You guys can see kind of what the graph looks like, okay? So when I put the equation in here, I put in the equation 20 over x. That's what equals y. So here again, we can kind of look at our measure. So at negative 10, it's 2. At, let's see, what do we got at negative 5? It's negative 4. And let's see what it is right about here, okay? So that's negative 210. So over here where our x values are positive, and notice there's nothing in here, okay? So here again, if we look at 2, yeah, if I could get to, having a hard time, y'all. So that's close to 210, right? This is, again, 5. We're going to plug this in, y'all. And then 10, yeah, 2 again. So let's look at let's go ahead and plug this into the equation. So when I looked at negative 10 for x, if I put a negative 10 in this table, I got negative 10. So what is 20 divided by negative 10? That's negative 2. And we don't want to go bigger than that because our graph's not bigger than that. So then we could go with negative 5 just to see. And when I divide 20 by negative 5, I get negative 4. When I divide 20 by negative 2, I get negative 10. And then if I were to put 0 in here, y'all, I would get an error, okay? And we saw that on the graph because there is nothing there, okay? There's actually, yeah, if we put negative 1 in there, we would get negative 20, right? So that won't even fit on our graph. So then let's go back up the same way we did here. So 2, 5, and 10. And here again, we're going to get, sorry, 10 and 4 and 2. So you're going to see that this is a different looking graph than anything that we've done before, okay? So at negative 10, we've got negative 2, so that's where it is right there. At negative 5, we're at negative 4. That's right there. And then at negative 2, we were at negative 10, right? So 1, 2, negative 10. Okay, so this graph is going to be a curve out here, and that's what it looked like a minute ago too, right? Okay, it's not the best pretty curve, but y'all get my drift. And then remember, there's nothing going to go across where that origin is. So again, we're going to go at 2, 10 right there, and then at 5, 4 right there, and then we're at 10, 2 again. So right there. Okay, so once again, our graph is going to look something like this. Sorry, I'm not getting that point perfectly, but y'all get the drift, okay? So that's what a our inverse variation graph looks like. And it's, if you notice what's happening with these points, right? So they're inverses of each other. They actually reflect over the origin. Y'all see that? Okay. So we're going to do a couple of these together. So on this one, it says the time t needed to compete in a certain race varies inversely as the runner's average speed s. So on this one, we're going to say that time is equal to k divided by s, right? So this time we're given that the time was 2.97. And that k divided by what? What was our speed, y'all? It was 8.82. So once again, we're going to multiply both sides by our 8.82, right? So that's going to give us, I got 26.1954. And that's equal to our k. So then our equation is going to be t equals 26.1954 divided by s, right? So then it says, what is the average speed of a runner who completes the race in 3.5 hours, right? So that's our time. So we're going to say 3.5 is equal to this 26.1954 divided by s. So how do we get rid of that s again, guys? Yes, we multiply both sides by it. So that's going to give us 3.5s equals 26.1954, right? And then we're going to divide both sides by the 3.5 because we're trying to find the speed, right? So we're going to divide both sides by the 3.5. So our speed is going to be equal to 7. We'll just say 5, right? I guess we could say 7.48, sorry, 7.48. My bad, y'all. 7.48. We're just going to keep it the way it was. So again, this is going to be what? Miles per hour. Okay? So to recap, when we have direct variation, the equation is y is equal to k times x, whereas when we have inverse variation, we have y is equal to k divided by x. And makes sense, right? Because if it's inverse, we're going to actually change the operation. So we had multiplication, it's going to change to division, okay? So a rational expression, that's what we're going over next, y'all, is a quotient. And what does that word quotient mean, y'all? Doesn't it mean division? Okay, so it's a quotient of two polynomials. So when identifying the values for which a rational expression is undefined, we identify the values of the variable that make the original denominator equal to 0. So what we're going to do when we're trying to find our undefined values, y'all, is we're going to set our denominator, our factors, actually, let's just say it this way, set the factors of the denominator equal to 0. Okay, that's what we're going to do. You'll see that in just a second. Okay, it'll make more sense in a minute. All right, so now, this is simplify. Identify any x, and then identify any x values for which the expression is undefined. Okay, so the very first thing we're going to look at here is we're going to break this up. So it's going to be 10 over 6. Doesn't that reduce to be 5 over 3? Because both are divisible by 2, right? And then we're going to talk about this other value, which is the x to the 8th divided by the x to the 4th. Well, isn't that really x to the 8th minus 4? Y'all remember anything that's in the denominator is negative, right? So this is going to be equal to x to the 4th, right? So our final answer is going to be 5 over 3 x to the 4th. Okay? Now, when it's asking about our undefined, we're always going to take what's in our denominator. So we've got a 6x to the 4th, and we didn't really have to factor anything out of that. Set that equal to 0. Divide both sides by 6. So our x to the 4th is equal to 0, which means if we were to take the 4th root of this, right, wouldn't we still get 0? So when is this undefined? When x is equal to 0. So x can never equal 0 here, because remember, you can't divide by 0. So if we had 0 in there for x, that would be when this equation would be undefined, right? So that's what it means by undefined. We can't have a 0 in the denominator anytime, okay? So on this next one, we're going to, again, do the same thing. And listen, you guys, once you factor the denominator, you can always set the factors equal to 0 right at the beginning. So we could do this one immediately. So we could say 6n equals 0, divide both sides by 6, right? So that means n equals 0 again. So n cannot equal 0. Y'all got me? Why? Because if it equals 0, then our denominator is 0, and you can't divide by 0, okay? So now we're going to do, again, this 4. We're going to factor out, what can be factored out of 4n and negative 10, y'all? Yes, a 2. So we're going to have 2n minus 5, right? So, and then what can be factored out of the denominator? Another 2, right? So that's going to give us what? 3n, right? So what do you notice cancels out? What do we see on the top that's also on the bottom? Yes, the 2. Okay, so that's going to give us our answer, whatever's left. So it's going to be 2n minus 5 over 3n. And that is our answer, okay? Got it? This was our answer over here. This is our answer here, okay? Okay, so when we taught you guys factoring, we taught you this bottoms up method, but in this case, I'm going to teach you, I'm going to go back to something I taught you guys before, which was the drop down method, okay? So what I'm going to do is I'm going to put my 6x squared plus 7x plus 2, right? And we're still going to do this. This is going to be 12, right? X squared, okay? So we're looking for the factors of 12x squared, but this time we're going to put our 6x here, and we're going to put our 6x here, okay? So now what we're going to do is we're going to see what are the factors of 12 that add up to be 7, okay? That's what we're asking ourselves. What are the factors of 12 that add up to be 7? So that would be plus 3 and plus 4, right? So now we're looking for our GCF, okay? So GCF here is 3, right? Whoops, of 6 and 3, isn't it 3, y'all? So the GCF is 3 here, and what's the GCF of 6 and 4? It's 2, right? So now what we're going to get here is we're going to get 2x plus 1, and over here we're going to get what? 3x plus 2. So those are our factors, okay, for our numerator. And I'm going to put an n out here just to help myself remember, okay? Now we're going to do the denominator, okay? So now we're going to do our 6x squared minus 5x minus 6. And once again, I'm going to multiply these together. So this is going to be 36x squared. So here again, I'm going to put my 6x and my 6x, okay? What are the factors of 36 that add up to be negative 36? Whew, almost missed that, y'all. What are the factors of negative 36 that add up to be a negative 5? So our factors of 36 are 1 and 36, 2 and 18, 3 and 12, 4 and 9. I think that's it, 4 and 9. So which one has to be positive? Which one has to be negative? So we got minus 9 and plus 4, right, y'all? Negative 9 times 4 is negative 36. And when I subtract 9 from 4, I get negative 5, right? Okay. So again, we're looking for our GCF here. Okay. So we're going to see what's our GCF of 6 and 9. That's a 3. What's our GCF of 6 and 4? That's 2. So what we're going to get here for our denominator is going to be 2x minus 3, right? And then over here, we're going to get what? 3x plus 2. Do y'all see that? Okay, so now, one of the things that we have to do right now that we have our denominators, we have to set both of these equal to 0, okay? So we are going to do that because that's when our graph is going to be undefined, okay? Or when our equation is going to be undefined. So we're going to say 2x minus 3 equals 0. So that means 2x equals positive 3, and that's going to be x is equal to 3 over 2, right? So that means x cannot equal 3 over 2. And then we've also got 3x plus 2 equals 0. So we're going to subtract the 2, so 3x equals negative 2. Wait, let me fix that, negative 2. And then we're going to divide that by our 3. So x is equal to negative 2/3, which means x cannot equal negative 2/3. So those are the two values when our equation cannot, x cannot be equal to those two values, because if it does, then we're going to get 0 in the denominator, okay? So now what we want to do is take our numerator and denominator, put them over each other. So we're going to do our 2x plus 1 times our 3x plus 2, and we're going to put that over our denominator, right, which was 2x minus 3 over our 3x plus 2. Now, what do you notice right now? Hopefully you notice that we have the same factor repeated in the numerator and the denominator, so that means it's going to cancel out. Do y'all see that? So that means our answer then is going to be what's left, so it's going to be this right here, okay? So our answer is going to be 2x plus 1 over 2x minus 3. So we got another one to do together, and then you guys are going to do a couple by yourselves, okay? So here again, let's factor this numerator. So we've got negative x squared plus 4x, okay? So this is our numerator again. So looks to me like I'd factor out a negative x, right? So let's do that. So if I factor out a negative x times, that would be x plus 4, right? No, minus 4, sorry. X minus 4, y'all, because I factored out a negative, right? So that's going to be x minus 4. All right, now let's do our denominator. So our denominator is x squared minus 2x minus 8. So that's going to be equal to, let's think of the factors. So we got an x and an x, right? So the factors of negative 8 that add up to be negative 2 are minus 4 and plus 2, right? So now, wow, those fit right over each other. So we can actually start canceling out right now. But what we need to remember is we got both of those factors in the denominator, we must set them equal to 0, because that's where our values of x cannot be. So that's where our x is going to be undefined. So we're going to say x minus 4 equals 0. So x cannot equal 4. And we're going to say x plus 2 equals 0. So x cannot equal negative 2, okay? Again, if we put those values in the denominator, it's going to give us a 0 in the denominator. We can never have a 0 in the denominator because we cannot divide by 0, okay? So now let's look up here. What do you guys see repeated in the numerator and the denominator? Me too. Those two values right there, right? So x minus 4. So that means our answer is going to be negative x over what? X plus 2. So that's what happens when we simplify this function, okay? So, all right, let's see if you guys can do the next few and come back to me when you're done. So hopefully you've completed these 3 problems. I'm going to go ahead and go over them now. So you can stop the video in between if you want. All right, so we got the 16 divided by the 8. That's going to give us 2, right? And then we've got the x to the 11th over the x to the 2nd. So remember, if it's the denominator, we're going to subtract it. So it's going to be x to the 11th minus 2, which is going to give us x to the 9th, right? That's supposed to be a minus, y'all. So this is going to be 2x to the 9th. That's going to be our answer. And remember, again, we're looking at our excluded value, so we're going to set that 8x squared equal to 0. Divide both sides by our 8. That's going to give us x squared equals 0. We're going to take the square root of both sides. So again, x cannot equal 0. Remember, the reason for this is because we cannot have a 0 in the denominator, okay? So we got our next one. And again, you can pause the video here, do the next one, and then come back to me. All right, so on this one, we've got x plus 2 in the numerator. And then down here, we're going to factor out a 5x, okay? Hopefully you see that there's a 5 that's a factor of both of theirs and an x in both. So that's going to give us x plus 2. So again, we're looking to see what we can eliminate that's on the top and the bottom. And hopefully you see that there's an x plus 2 on both. So that's going to give us 1 over 5x, right? Now, remember, we got to set both of those factors, the 5x and the x plus 2, equal to 0. So we're going to say 5x equals 0. Divide both sides by 5. So that means x cannot equal 0. And then we've got x plus 2 equals 0. So x cannot also equal negative 2, okay? All right, our last one over here is x squared. So again, we're going to do our numerator denominator thing again, okay? So we're going to factor this x squared plus x minus 2. So what are the factors of, when we multiply these together, negative 2x squared that add up to b. So we're going to be x, so that's going to be a positive 1, right? There's a 1 there. So that's going to be x plus 2 and x minus 1, right? Okay, now in our denominator, that was our numerator. Now our denominator, we're going to, again, do the same thing. So we've got our x squared plus 2x minus 3. So here, we've got our, again, x and x. And then what are the factors of negative 3 that add up to be positive 2? So that would be what? Plus 3 and minus 1. So noticing again that we have the same factor in the numerator and the denominator, that x minus 1. So it's going to cross out and we're going to be left with x plus 2 over x plus 3. Now recall again that we have to set those factors of that denominator equal to 0. So we have to say x plus 3 equals 0. So x cannot equal negative 3. And x minus 1 equals 0. So x cannot equal positive 1. Okay? So we have a couple extension questions here. You guys can do this or not. It's your call, but these are a little harder. Okay? So I'm looking at this 14x to the third minus 130 plus, 130x squared plus 36x. So I noticed that everything's divisible by 2 and x. So I'm going to factor that out first. So that's going to give me a 2x. That's going to give me a 7x squared minus 65x plus 18. So then I'm going to actually multiply these two together right here. So that's going to give me, what did I get? 126, okay? So I'm looking at the factors of 126 add up to be negative 65. So I'm going to divide it by 2 just to see, okay? So I got a 2x. So I'm going to do my 7x here like I did on the prior one and a 7x here. What are the factors of 126 that add up to be negative 65? And I'm thinking it's going to be minus 63 and minus 2. 63 times 2 is 126. Yep. Okay, so now divide both of these, or what is the GCF here? The GCF here is what, y'all? 7, yeah. So this is going to be 2x, and then that's going to be x minus 9, and then this is going to be 7x minus 2. So those are the factors there, okay? So that's our numerator, right? So I'm going to put an n on that. Now we're going to work on our denominator, okay? So our denominator, let's see, I think 4 is a factor of all of that, y'all. So let's factor a 4 out and see what we get. So that would give us x squared minus 7x minus 18. Yep. Okay, so now let's talk about this. So what do we get here when we do this? We're going to get, okay, 4, and then we're going to factor this, okay? So we get x and x. What are the factors of negative 18 that add up to be negative 7? That would be negative 9 and positive 2, right? Okay, so now do you guys see any common factors in the numerator and the denominator that we could scratch through or eliminate? So that one right there, the x minus 9, x minus 9, right? And then do you notice that the 2 and the 4, but this leaves us a 2 down here, okay? So what our answer is going to be is x times 7x minus 2 over 2 times x plus 2. Now remember, we still have to state our undefined terms. So we got to take this x minus 9, set it equal to 0, so x, it cannot be equal to 9, right? And then we got to do our x plus 2, same thing, equals 0. So x cannot equal negative 2. So those are the places where our denominator would be undefined, okay? All right, let's see if I can move this over. Hold on a second. Okay, let's see if we can do this next one. I'm going to put a line down here, guys, so you guys can see where I'm working. And let's just go ahead and erase this a little bit. Okay. All right, so now once again, we're going to factor what's in the numerator and what's in the denominator. So I'm pretty sure everything in that top factors by 6. Okay, so let's try that. So this is our numerator again. So we've got 6 times x squared plus 4x, and that's going to be minus 21. So then we got a 6 again. So what are the factors of x squared? Let's see. This is going to be, what are the factors of negative 21 that add up to be positive 4? So I'm thinking that's a plus 7 and a minus 3, right? Okay, that's our numerator. Okay, so now we're going to work on our denominator again. Okay, so this time, looks to me like we have a 10x squared and everything as our common factor, right? Our GCF. So that's going to give me x squared plus 5x minus 14, right? So again, we're going to leave that 10x squared, and then we're going to factor this some more. What are the factors of negative 14 that add up to be 5? So that would be plus 7 and minus 2, right? Okay, so now we're going to put these over each other and see what simplifies. Okay, so we've got our 6x plus 7x minus 3, and we're going to put that over our 10x squared and our x plus 7 and our x minus 2. Okay, so looks to me like the 6 and the 10 could reduce, right? So 6 and 10, so that would be 3 and 5, right, guys? So that's going to be 3/5. So we got that part. Our x plus 7 is going to cancel, right? We still have the x squared in the denominator, though, and we have the x minus 3. So this is going to be x minus 3 up here. We have 5x squared, right? And then we got that multiplied by x minus 2. Okay, now remember, we still have to set, now we got 3 factors in the denominator. We got to set all of those equal to 0, okay? So what we're going to do is we're going to do our 10x squared equals 0. So that divide both sides by 10. So that's going to get rid of the 10. So we got x squared equals 0. Take the square root of both sides, right? So x cannot equal 0. And then we've also got the x plus 7. So x plus 7 equals 0. So x cannot equal 7, or sorry, negative 7. And then we've got our x minus 2 equals 0. So x cannot equal 2. So those are where our x would be undefined, okay? All right, so we got this last one over here. So let's go ahead and work this one. So on this one, looks to me like there's a 2x in the numerator, right? So we got our numerator again. So we've got a 2x, and when we factor that out, we get 5x squared plus, or sorry, minus 30, no, that's plus 34, right? Plus 34x minus 7, right, y'all? Okay, so if we multiply a times c, that's going to be negative 35, right? So we got 2x, and I'm going to do this the way we did before, okay? So I'm going to do a 5x here and a 5x here, and I'm going to do, what is that going to be? Minus 35, so that's going to be plus 35 and minus 1, right, y'all? Okay, so this has a GCF. Y'all see it? This over here has a GCF. That's going to be 5. So this is going to be 2x times x plus 7. And then this is going to be 5x minus 1. So that's, again, still our numerator, right? Now let's work on our denominator, okay? So our denominator, looks to me like, I don't think that it just has an x, right, y'all? So let's factor out the x. That's going to give us 5x squared plus 38x plus 21. Okay, so again, we're going to multiply these together. That's going to give us 105, right, y'all? 105, okay. So I'm going to do my x out here, and I'm going to do my 5x and 5x again. Okay, so we're looking at what are the factors of 105 that add up to be 38. So again, what are the factors of, and wait, is that a positive or negative? That's, yeah, that's positive. So it looks to me like it's going to be 35 and 3, y'all. 35 and 3. 35 times 3 is 105. 35 plus 3 is 38, right? So plus 35 and plus 3. Let me do a different color here, y'all, so you can see what I'm doing. 35 and plus 3, okay? So now that was our denominator, right? So we're going to put these over each other. So we get a 2x and an x plus 7. Oh, this is divisible by 5, right, y'all? So wait, let me go back up here and fix this so we can make this simpler, yes? So this is our denominator, so it's going to be x, and this is going to be x plus 7, and then 5x plus 3. Okay? So that's our denominator, and so we need to put our numerator over our denominator now, right? Okay. So our numerator was 2x and x plus 7 and 5x minus 1. Our denominator was x and x plus 7 and 5x plus 3. Okay, so where do we have common factors that we can go ahead and mark out? So we have an x and an x, right? We have the x plus 7 and the x plus 7. So this gives us 2 times 5x minus 1 over 5x plus 3. That's our answer right there, okay? So now we have to, again, look at where our zeros. So we're going to look at this whole denominator right here, guys. Remember, all of this. We're going to set all of this equal to 0. So we've got x equals 0, so x cannot equal 0, right? We got x plus 7 equals 0, so x cannot equal negative 7. And then we've got our 5x plus 3 equals 0, so that's going to be 5x equals negative 3. Divide both sides by 5, so x cannot equal negative 3/5 either. Okay?